Well, we'll try this experiment, see if it works, and we'll see if we can see the reading on the board. If it works, let's start doing this. Okay? If it doesn't work, it doesn't work, but like I said, at the end what I'll do is I'll bring it up to the board, and then obviously I'll try to remember to start doing that from now on too. I appreciate the feedback. It always helps. So, all right. Evaporation, condensation. So from the video, why don't we start with those two terms, and then we'll lead it into the conversation on gases. So evaporation. According to the video, then, what is evaporation?
The molecules heat up and up, and they're moving too fast. They can't control them. They jump out.
Okay, molecules are, you said, heating up, and they're moving too fast that they
lose control.
They lose control. Okay, what are the molecules? What state of matter are the molecules to begin with? And they turn into?
Yes.
Okay, so liquid molecules turn into gas. Where in the liquid does this occur? At the top, at the surface. So liquid molecules turn into gas at the surface of the liquid because the molecules were going so fast. Because they were heated up and lost control. I think that pretty much combines all of what you guys are talking about. Okay? Liquid molecules turn into gas at the surface of the liquid because the molecules are going so fast because they were heated up and they lost control. Now, so it's a liquid to gas. Can you think of any other term for a liquid going to a gas? Boiling. Is this the same thing as boiling?
No.
No? How's boiling different?
Boiling is hot, but it's not hot enough.
Okay. Okay, boiling is hot, but okay, is boiling, do you have to do something specific to get it to boil?
Yeah, heat up so high.
How high?
The boiling point.
What's boiling point of water?
100 degrees Celsius.
Oh, okay. So you have to heat it up to 100 degrees Celsius, okay? And then liquid turns into a gas. Now, with evaporation, do you have to heat it up to 100 degrees?
No.
No? Okay. How cold can you get it and it'll still evaporate?
It's freezing point.
Okay, why not any lower than freezing point?
No, it's solid.
Yeah, then it's solid. And then you have another process that can happen, and it's not a term you have to worry about, it's called sublimation, where you have a solid turning into a gas. That happens when you have frost that goes away. That's also the process for like dry ice, CO2. Solid CO2 is dry ice, okay? Solid CO2, aka dry ice, will go directly from a solid to a gas and skip the liquid stage. That's what's called sublimation, going from a solid to a gas. So, not that you have to worry about that term, but just putting it in terms of evaporation. So, evaporation is liquid to a gas, and so we know it can't happen at 0, and if it's at 100, it's boiling. So then what's that tell us about what temperatures it can happen at then?
1 and 2.
Between 0 and 100. Okay, so occurs between 0 to 100 degrees Celsius. Okay. Now, does this process happen at the same rate, or is it dependent on the temperature?
Depending on temperature.
Okay, is it faster when it's warmer or faster when it's colder according to the movie?
Faster when it's warm.
When it's warmer, right. They showed the diagram of the sunlight shining on the fishbowl and how that water would go away a lot more quickly. So then the guy had the aha moment, and he zipped it over to the refrigerator. And that's when we got the condensation. Okay? So, occurs faster at warmer temps. Occurs faster at warmer temps. When temperatures warm up, what happened to our particles again? What does temperature do to the particles? It makes them move faster. Yeah. So does it make sense then that this process is going to happen faster because we have warmer temps? The faster your particles go, the more they're going to jostle off the top. Yeah. Okay. So then the guy put the fish bowl into the fridge, and he opened it up, and the fish is he's just shivering. Okay. And talked about condensation. Well, what's condensation?
When air particles hit something cold,
Mm-hmm.
and they turn into a liquid.
Yeah.
So it's a gas to a liquid.
Yeah. Air particles hit a cold object and turn into a liquid. So in terms of the speed of the particles, what happens to the particle speed then?
It's
Slow down. Yep. There we go. So the air particles, a cold object, turn into a liquid. Particles slow down. It tends to happen when you have more temperature extremes. Something really, really cold with something a lot warmer than it. So let's say, like the other day when I brought that ice, and I think it was yesterday, when I brought that ice out of the freezer, boy, we had condensation right away almost. Because it's nice and cold in that freezer. And in the room I try to keep it around, I'd say I probably try to keep it around 72 degrees in here. I try to keep it comfortable. Obviously, the air gets cold pretty quick in here. Although on a day like today, it should stay nice and warm. It's supposed to be a high 55 today. So, yeah. Yep. Spring's on the way, gang.
Yes.
Spring's on the way. So, that's what condensation is. Okay. Even right here, I can see a little bit of it on my lemonade from lunch. I had ice in here. And by the way, again, just to make certain that you know, where's that liquid coming from?
The air.
The air, yeah.
Vapor air.
Water vapor. And if you noticed how they spelled it, take a guess on where the cartoon was made. Did anyone notice how they spelled vapor?
V-A-P-O-R.
They did not, no.
They spelled it U.
Nicole?
With a U.
Yeah, they spelled it V-A-P-O-U.
France.
Not France, they don't speak English. Huh? They don't speak English.
In Costa Rica.
England? It could be, but it's actually not England.
London.
That's in England.
Let's see. That direction.
That
The
was
country that Mr. Unwin hails from.
Canada.
Yeah.
Canadian.
Canadian. Yes, Canada. It was actually made in Canada, so they tend to put
Speak Canadian.
that OU together in order to make that, the or sound. Vapor. So, but yeah. So naturally, and I was telling this with the other two classes too, that our air contains water vapor in it naturally. The drier it is outside, generally the colder it is, the warmer, the more moisture there is. Hence the reason why in the wintertime, first of all, that's why I've kept this in my classroom for anyone that, gets dry hands, especially like this time. Well, actually not so much this time of year, although it's still good practice. Throughout the school year, you're often washing your hands and the soap here dries out your hands a lot. And naturally, the colder temperatures, less moisture in the air, that's going to dry out the skin in your hands. So put on a little bit of lotion to act as a moisture barrier. It seals the moisture in your hands in. So, anyway. Then also for like people that get bloody noses, it's because of the dry air. Or if you get, I didn't even think of, I mean, this is just stuff I was talking about with the other two peers, so I wasn't even thinking of you about that one, Tyler. Or if you get, if you need to use chapstick quite a bit because you get dry, cracked lips, that's why. The dryness of the air.
Well, they do all the time.
So, not fun, I know.
I
Not
never
fun.
used to have it until this year, and then all of a sudden I have
In
it.
the wintertime.
Okay, now, in reference to gases then, so what can we say about the temperature of gases?
Burn. Hot.
Hot, yep.
Smoking.
So temp of particles is hotter. Okay? Temp of the particles is hotter. What, let's see, we already got the spread out. What about their speed?
They're fans.
Right.
Fans.
In fact, I'm going to put up the three. The temperatures are the hottest, and the speed is the fastest. Yep. Freaky fast delivery. That's right. So the gases, temperature of the particles is the hottest, and the speed is the fastest. Okay? And we have arrived at the end of talking about solids, liquids, and gases. Questions?
Save.
Okay, now, I'll bring the camera up here, and while I'm talking, yeah, Blaze, and others. I'm trying to think if anyone was gone today.
Curtis. Right, Curtis.
Okay, so solids.
Mustache boy. Yeah.
So that's solids, liquids,
Yeah, dude.
Go home, take a shower, and then
He did, I heard him.
that's liquids, gases,
Hey, she'll be all like, in the pen. Because the string kind of gets in the way.
Someone want to turn on the hot plate to 10 back there, please? Temperature of particles, hottest, speed, fastest. It's gases, evaporation.
Oh, cracked it to 10.
Molecules turn into a gas at the surface of the liquid because the molecules were going so fast because they were heated up and lost control. Occurs between 0 and 100 degrees Celsius. Occurs fastest at warmer temps. Condensation. Air particles hit cold object and turn into a liquid. Particles slow down. Okay, that's where we're at. Now, I'm going to direct your attention to back here then. I'll set up the tripod right over here so you can see it well. Probably not the greatest, but hey. Yep. Now, we've got in the one, we've got both of them are mixtures. One is of rubbing alcohol and some red food coloring. The other one is of water and green food coloring. Okay. So water with green food coloring, and this one being rubbing alcohol with red food coloring. Okay. All right. While this is starting to heat up here, a side note that your homework for tonight is 3-1 worksheet 1. You should notice it was shared in your email probably around second period this morning. I sent it right after first hour, so you all should have that in your email. And like usual, of course, you can download it, work on it as a PDF. You can view it and write your answers onto a piece of blank paper, or you can always print it off, your choice. Okay. So that will be your assignment. And as I noted, when you can type in a message. I just typed in, this is your assignment for tonight, due first thing in class tomorrow. Okay. Now, any predictions on what you think will happen here with the liquid, huh?
Steam is mine.
Steam, okay.
One will evaporate first.
Will evaporate first, okay.
One of them can be
There's less of it.
Any idea why you think I've got these glass tubes in here with stoppers?
They don't run.
No, so you can tell is when it starts to steam because you see the condensation build up on the tube.
Well, the condensation will actually build up more on the side here, and it is in the tubes, I guess you could say too. But, okay.
So the water has to warm up first.
I just want you to pay close attention for a couple moments here and see if you can start to notice anything in regards to either liquid or and obviously, if you'd like, you can come closer too. You don't have to sit back there. So, whichever be your preference.
We're supposed to say what we're seeing? We're just looking at
Yeah, anything that you happen to notice.
Oh, the red.
Well, the
What's going on?
water is like blockier.
It's getting a little
There's more
foggy.
condensation on the water.
Carter, you're saying something about the red one.
It's starting to,
Yeah, the bottom of it's turning dark.
the red's starting to move.
Red's starting to move?
Yep.
What direction?
Up.
Up. And the red is this rubbing alcohol. Okay. So why do you suppose it's moving up?
It's less dense.
Okay. What's causing it to move up?
It's
The
turning
heat.
into a gas.
The heat. And what do we know happens when particles heat up in terms of their arrangement?
They bounce faster. Or they move.
They do move faster, but in how we drew them, as you heat up a liquid, what happens to the particles in terms of how they're arranged?
They lose their spring.
They lose their spring and what?
Spread out.
They spread out. What's another term for spreading out?
Oh, yes. What's it called? Free for all?
No?
Spread out. Right.
Think of this in reference to like concrete in a road. What does concrete in a road do in the summertime when it gets hot?
Expand. No,
Huh? It expands. Yeah. Expands. This is expansion. Perfect. We'll come back to this first thing tomorrow.